This is my third, and certainly not my last video on derivatives. And I wanted to keep clarifying what we're trying to find here. Now, in central Illinois, we have a highway. It's called US 51. And you'll see that it kind of starts around Bloomington, Illinois. It goes through Clinton, Illinois, and it keeps going right on down to a little town called Centralia, Illinois. Now, much of this highway is 65 miles an hour. Now, not all of it is, but quite a bit of this highway now is 65 miles an hour. There are places when you're driving down the highway, you're going at 55 miles an hour, and sometimes you'll go even less. That's right. There's a little town down here called Assumption, Illinois, where you're going to go only 30 miles an hour. Okay? So, for you to say, hey, if you travel down US 51, you're going to go 65 miles an hour the whole way from Bloomington to Centralia, you're not correct. Okay? So, how fast you're moving down the whole dang highway from Bloomington to Centralia is going to be based on how fast you're moving between certain spots. Certainly, when you reach Clinton, Illinois, you have to slow down. If you don't, you'll get a ticket. And of course, when you get past Clinton, you can speed up again. But remember, it takes time to slow down your car, to speed up your car, and there's a period of time when you're going to be driving slower. Through Clinton, through Decatur, through Pana, through Vandalia, that sort of thing. You're going to drive slower. It's through Assumption. That's another one. You're going to drive slower on that same road through those little towns than you would be on the main highway. Okay, the main highway goes through these little towns, so you have to slow down. If you don't, you get a traffic ticket. So, what we're trying to do in derivatives is we're trying to derive a speed that you're going at a certain interval of time. Okay? And at one particular point, as you're going through the town of Clinton, Illinois, or the town of Assumption, Illinois, or the town of Vandalia, Illinois, you're not going 65 miles an hour. Now, when you get out of Bloomington, you get on the main part of that highway, you are going 65 miles an hour. Once you reach Assumption, Illinois, you're not going 65, you're going 30. And so we have to calculate your velocity at the moment you enter Assumption, as opposed to calculating your velocity when you're going down between Bloomington and Clinton. Okay? And believe me, there's a big difference between those two. Also keep in mind that, I hate to say it, but just like any other highway across the United States, there are things called deer that cross the highway. And let me tell you something, if you don't try to slow your car down to try to not hit the deer, well, you're going to hit the deer at full force and bust up your car pretty bad, and maybe bust yourself up at the same time. And let me tell you something, if you do manage to hit the deer, if you hit the deer at a certain speed, it's going to be a little different than if you hit the deer at another speed. Let me tell you something, hitting a deer at 20 miles an hour might not cause too much damage. You hit a deer at 60 miles an hour, well, you get up in the hospital pretty dang quick. So, that's what we're talking about in derivatives. The difference between hitting a deer at 20 miles an hour and at 60 miles an hour can mean the difference between whether you live or you die. It's that simple. And that's what we're trying to figure out here. And I already showed you in a previous video that if you're dropping a ball from a building and you're calculating things between tenths of a second, according to that equation that I had presented to you, you saw that the ball dropped 16 feet in just 1/10 of a second. And it kept doing that consistently. And that's if the gravity doesn't change, and that's if there's no wind shear, and that's, there's so many ifs about it. Wind shear and gravity and whatever can change how the ball drops, where it drops, so on and so forth. Let me tell you something. When you're dealing with a china plate, if it falls out of a bottom cabinet onto the floor about maybe about a foot, it probably won't break. It might chip a little, but it probably won't break. But if you got a 6-foot guy and he actually trips and falls, and that plate goes sailing through the air and lands on the ground, it's going to shatter because it's China. Okay? And China plates do shatter at certain speeds and certain velocities, so on and so forth. So, it's just like a tornado. Let me tell you something. If somebody took, let's say, a box of playing cards. Okay, there's a 52-card deck and a box of playing cards. They took it and they just flung it at you. Yeah, it'd hit you and it'd probably sting a little bit, but it wouldn't kill you. Have a tornado at 200 miles an hour pick up that same box of playing cards, and that playing cards could kill you. The playing cards didn't change, but its velocity changed, so therefore it became a deadly projectile rather than just a mild irritation. Let me tell you something. If you take a deck of playing cards and you smack it against a garage, it might cause a small little dent in the garage, or the garage door, that is. Smack it against the garage door, might cause a little dent. You have a tornado throw it through there, it might go right through the garage door, through the garage, and out to the middle of the cornfield behind it. So it's very important to figure out instantaneous speed to determine how deadly something can actually be. And that's what we're going to cover in our next derivative video. Now you're getting an idea of why it's so important to figure out instantaneous speed. Because let me tell you something. In a car wreck, if somebody knows they're getting ready to hit another car, they're going to try to stop their car. So they're not going to be traveling at 40 miles an hour when they impact the car. They may be traveling at a lot less. I know because I had a car wreck and I knew I was getting ready to hit the car, so I did slam on the brakes just before I made the impact. And by doing so, it didn't cause as much damage as what it would have been if I hadn't tried to throw another brake. See what I mean? Alright. I will tell you more in a future video, so stay tuned.